Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. Today topic is okay. So today completely we will discuss about all chapters at once. At once we will discuss about important points. Okay, so important points we'll discuss. Important topics we'll discuss, and where we need to concentrate. What type of questions they will ask in the exam. Okay, everything we will discuss. Everything we will discuss. So stay tuned. Stay tuned to the CBSE Grade-10 physics student the brand here. So light reflection and diffraction. So first coming to the first chapter, light reflection reflection and refraction. Light reflection and refraction. So coming to here, important questions also will discuss. Important questions where they will concentrate and what type of questions they will ask. So especially related to this light chapter, so they will concentrate on ray diagrams and problems too. Ray diagrams and problems also they will ask. And so previously so in many videos I given few example problems, so there you have to concentrate. And here also today also I'll give few more questions where they will concentrate, what questions they will ask, everything we will discuss about it. And coming to especially in the light reflection diffraction chapter. Okay, so right from starting onwards we will discuss. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Where light incident on the surface. Okay, so reflection. So here is the point, reflection. When light is incidenting on the surface, so it will be reflected back. The bouncing back of the light from the reflecting surface is called reflection of light. So here this is incident ray, and this one is the reflected ray, incident ray, this is the incident ray. And coming to the reflected ray, and coming to the normal line, reflected ray. So this is the normal line. So the line which is perpendicular to the plane surface, actually it is imaginary line. So the line which is perpendicular to the plane surface, that is imaginary line. So we are drawing with the dotted lines. So the angle between incident ray normal line is called angle of incidence. Angle between reflected ray normal line is called angle of reflection. And angle between reflected ray and deviated line is called angle of deviation. So here mainly we need to concentrate. So here based on this topic they will ask one question, that is when light is incidenting on the surface. Okay, when light is incidenting along the normal line. So very important, MCQ's point of view, very important. So definitely this type of question can be expected for MCQs type of question. Okay, for MCQs, when light incident along the normal line. So when light ray incidenting along the normal line like this. Okay, so here you can observe, if the light ray passes or moves along the normal line, angle of incidence is 0, angle of reflection is 0, and angle of deviation equal to 180 degrees. Angle of deviation equal to 180 degrees. So keep in mind, so this question will come for exam. So for a 1 mark, or sometimes they will ask for okay, MCQs part also. Okay, so very important. Make sure that so you are preparing this one. Here angle between incident ray normal line is called angle of incidence. Angle between reflected ray normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. So the bouncing back of the light from the reflecting surface, is called reflection of light. Okay, so incident ray, reflected ray, normal line. And coming to the one more point, the angle between incident ray and plane surface. So the angle between incident ray and plane surface is called glancing angle of incidence. Angle between reflected ray and plane surface, glancing angle of reflection. Glancing angle of incidence. So glancing angle of reflection. Okay, so glancing angle of incidence and glancing angle of reflection, very important. And coming to laws of reflection, laws of reflection. So what are the laws of reflection? First point is incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Coming to the next one, angle of incidence is equal to angle of reflection. Okay, angle of incidence. Now coming to laws of reflection, incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. These are the laws of reflection. And coming to angle of deviation, so angle of deviation formula. So we can take, so angle of deviation, that is nothing but angle of incidence plus angle of reflection plus angle of deviation. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So from laws of reflection we can take angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence, 180 minus 2 angle of incidence, understood or not? And one more thing, so angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of reflection. So this is the formula. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Understood or not? So these points are very important. These points are very important. Next one. Okay, so now we'll go to the next, that is regular reflection and irregular reflection. Regular reflection and coming to irregular reflection. Regular reflection and irregular reflection. So let's start regular and irregular. So here I am taking the plane surface. This is the plane surface. Okay, so here they will ask, so example for regular reflection, where regular reflection takes place on plane mirror and still lake water surface, still water surface of lake. So these two examples we can say. So I am taking, these are the incident rays, these are the incident rays, these are the incident rays, understood or not? These are the incident rays, and these are the reflected rays, these are the reflected light rays, reflected light rays, reflected light rays. Incident light rays are parallel to each other. Incident light rays, incident light rays, okay, incident light rays parallel to each other, and reflector light rays are also parallel to each other. Reflector light rays, reflector light rays. So this is about regular reflection, regular reflection. Coming to irregular reflection, so irregular reflection is like this. Irregular reflection, regular reflection takes place on plane surface, whereas irregular reflection takes place on rough surface. So here you can take, these light rays are parallel to each other. Okay, so incident light rays are parallel to each other, but reflector light rays are not parallel to each other. Yeah, so incident light rays are parallel to each other. So I am taking here. Okay, so incident light rays are parallel to each other, but reflector light rays are not parallel to each other. So these light rays are moving in different direction. So regular reflection takes place on smooth surface and plane mirror. So regular reflection takes place on rough surface. So regular reflection takes place on rough surface. Rough surface. Example, wall and so wall and we can take cardboard also. Cardboard also we can take. Okay, so that is about regular reflection and irregular reflection. So next one, so we'll discuss about one more. That is about regular, this about regular reflection and irregular reflection. Examples point of view, very important. So where regular reflection takes place, where irregular reflection takes place. So examples are very important. Next one, object and image. So coming to object and image, so I'm taking here, so this the plane mirror. So I'm taking the plane mirror, this is the plane mirror. Okay, so I am considering here light rays are coming from this point, after reflection those light rays are meeting at one point. Here this the real image, the point of intersection of reflector light rays. Reflector light rays are meeting directly, that's why it is called real image. So if you are extending these incident rays, extended incident light rays are meeting at one point, that is a virtual object. Real image and virtual object, understood or not? Real image and virtual object. And coming to the next one, Coming to the next one, so I'm taking this the plane mirror. So from this, so from here light rays are coming after reflection. After reflection, those light rays are moving away from it. Those light rays are moving away from it. So here you can observe. You can observe. So here you can extend. Here also you can extend. So this is a real object and virtual image. Virtual image. Understood or not? From this point, light rays are coming. So from this point, light rays are coming. This is a real object. Real object. So after reflection, so extended. So we extended this light rays. Those extended light rays are meeting at one point. Their virtual image is forming. The point of intersection of extended reflector light rays. The point of intersection of extended reflector light rays is called virtual image. The point of intersection of directly reflector light rays is called real image. So then, so you can observe here, object is real, image is virtual. Object is object and image. Object is real, image is virtual. Object is virtual, image is real. I hope it is very clear. So just let me just understand the concept. Understand the concept. Object is real, image is virtual. Object is virtual, image is real. So here is the real image. This is a virtual object. So real object and virtual image. Real object and virtual image. Understood or not? So next one, so we'll discuss about so we will discuss about one more, that is nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So here you can take, so this is the object. So this is the object. I am taking this the object AB. Object AB. So when light rays is passing along the normal line, if the light ray is passing along the normal line, so you can observe here, okay. So if the light ray is passing along the normal line, so it is passing along the normal, what happens? It rebounds. So it moves in the same direction. It rebounds. So it moves in the same direction. Understood or not? So that's why. So that's why here also I'm taking, when the light ray is passing along here like this, it moves in the same direction. And here also. And here also. Okay, so here, okay, now when light ray is incidenting on it, along this one it will be reflected back. Here also we can take. So what type of image will form? Virtual erect and same size. Virtual erect and the same size of the image will form. So here you can take, here also, and if you are taking, and if you are considering, so the image will form here. So this is A dash and B dash, A dash and B dash. So object is real, image is virtual. Object is real. So point number one, object is real, image is virtual. Object is virtual, image is real. Coming to the point number two, object distance is equal to image distance. Okay, so object distance is equal to image distance. Object distance is equal to image distance. And coming to the third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. And also magnification of the plane mirror is +1. Magnification of the plane mirror is +1. Okay. So next one, coming to the fifth one. So magnification of the plane mirror is +1 and also shows lateral inversion. It also shows lateral inversion. First one, object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Point number one. Coming to the point number two, object distance is equal to image distance. Object distance is equal to image distance. And coming to the third one, height of the object is equal to height of the image. And coming to the fourth one, okay, magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And coming to, it also shows lateral inversion. It also shows lateral inversion. Okay, so what is the lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. The phenomena of converting of right side of the object appears to be left side of the image. The left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. I hope it is very clear. These are the points. So these are the nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Next one, so we'll discuss one more point. So that is, so object a plane mirror completed. Next one, spherical mirror. Spherical mirror. There are two types of spherical mirrors are there: concave mirror and convex mirror. Concave mirror and convex mirror. So I'm taking here. You can take this the concave mirror. So this is a concave mirror. First one here when reflection takes place inward. Reflection takes place inward is called reflection takes place inward. That is called concave mirror. Reflection takes place outward is known as convex mirror. Reflection takes place inward, that is known as convex mirror. So concave mirror. Reflection takes place inward, that is called concave mirror. Reflection takes place outward, that is called convex mirror. Convex mirror. Understood? I hope it is very clear. Reflection takes place inward, concave. Reflection takes place outward, convex. So now we will discuss about terms related to spherical mirror. Terms related to spherical mirror. So here you can observe the center of the imaginary sphere. This is center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. This is the midpoint of the mirror is called pole. The line joining of center curvature and pole is called principal axis. Okay, so coming to the point number 1, center of curvature. Point number 2, pole. Point number 3, principal axis. Principal axis. And coming to the fourth one, so the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point. After reflection, all light rays are meeting at one point. So here you can observe, after reflection, all light rays are meeting at one point, that is focus. So that is all. Generally it is called principal focus. Generally it is called principal focus. Simply we can say focus. Simply we can say focus. Coming to the sixth one, the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And so width of the reflecting surface. Width of the reflecting surface is called aperture. Width of the reflecting surface is called aperture. Understood or not? So center of curvature, pole, principal axis, radius of curvature. The line joining of center of curvature and pole is called principal axis, and the distance between center of curvature to pole is called radius of curvature. After reflection, all light rays are meeting at one point, that is called focus. The distance between focus to pole is called focal length. And width of the reflecting surface is called aperture. Width of the reflecting surface is called aperture. Understood or not? So these are the terms related to spherical mirror. Next one, ray rules. So ray rules we'll discuss. So related terms related to spherical mirror. So they will ask define pole, define focus, now define center of curvature, define center of curvature, define radius of curvature. These type of questions they will ask. And one more thing, if the light ray is passing along the principal axis, so angle of incidence is 0, angle of reflection also 0. Okay, so that is very important. And coming to the next one, so ray rules of concave mirror. So spherical mirror we can say ray rules of spherical mirror. Ray rules of spherical mirror. Ray rules of spherical mirror. Understood or not? So I am taking the concave mirror. This is a concave mirror. Pole, focus, center of curvature. Pole, focus, center of curvature. Light ray is coming from infinity. After that it passes through focus. Point number 1. Coming to the point number 2. Light ray is passing through focus. Pole, focus, center of curvature. Light ray is passing through focus. After reflection it passes, it moves towards infinity. And coming to the third one, Coming to the third one, light ray is passing. So this is the pole, focus, center of curvature. So light ray is passing through center of curvature. After reflection, it retraces its original path. It retraces its original path. Coming to the fourth one, light ray is incidenting at the. So here is the pole, focus, center of curvature. Light ray is incidenting at the pole, it reflect back. So like a reflection of light. So when light ray incident at the pole, it reflect back. So these are 1, 2, 3, 4. 4 ray rules. Coming to the convex mirror. This is the concave mirror. Concave mirror. Concave mirror. Next one is convex mirror. Convex mirror. So here you can observe convex mirror. Point number 1. So when light ray is passing, so pole, this is the pole, focus, center of curvature, light ray is coming from infinity after reflection. It passes through focus, point number 1. Coming to the point number 2, light ray is passing through pole, focus, center of curvature, light ray is passing through focus. Okay, so like this, after reflection moves towards infinity. And coming to the third one, light ray is passing through center of curvature, pole, focus and center of curvature. Light ray is passing through center of curvature, it retraces. And coming to the fourth one, okay, so this is the pole, focus, center of curvature, light ray is incidenting at the pole, so it reflect back. Okay, so I hope these are the points. These are the points. Is it clear? So understood? So these are ray rules. Next one we will discuss about image formations. Image formations of concave mirror and convex mirror, that is about spherical mirrors. Okay, so we'll discuss about spherical mirrors, image formations. So spherical mirrors, first one is, so first one concave mirror. So pole, focus, center of curvature, object is at infinity, image is forming at. So focus, first one, and coming to the second one. Okay, so after reflection, those light rays are meeting at one point. Here you can observe. This is the light rays, and here also light rays. Object is at infinity, image is forming at focus. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to the second one. So pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed beyond center of curvature. One light ray I am taking like this. It passes through focus. Another light ray is passing through center of curvature. So after reflection it moves. So the distance, so the image will form between C and F. Object is placed beyond C. Image will form between C and F. Nature of the image is real and inverted. Size of the image is diminished compared to the object. Image size is decreased. Okay, coming to the third one. Let's see here. So pole, focus, center of curvature, object is placed at C. One light I am taking like this, it passes through focus. So here another light is incident at the pole. Here you can see object at C, image also will form at C. Nature of the image is real and inverted. Size of the image is same size. Same size of the image will form at C. Same size of the image. Coming to the fourth one, object is placed. Okay, so here you can take pole, focus, center of curvature. Object is placed between C and F. One light I am taking like this. Passes through focus. Another light incident at the pole. It reflect back. So the image will form here. Okay, object is placed between C and F. Image will form beyond C. Beyond C, nature of the image is real and inverted. Size of the image is enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. Understood or not? Coming to the fifth one. Okay. So here you can observe. So pole, focus, center of curvature. Object is placed at F. Okay. So one light I am taking like this. So it passes through focus. Another light ray through center of curvature we can take like this. Okay. So here. So you can take. So those light rays. So these light rays will meet at infinity. It will become parallel lines. Those light rays will meet at infinity. Object is at F. Image is forming at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Highly enlarged. Understood or not? And coming to the sixth one. So sixth one is very very important. Dentist will see. Dentist, we will use this mirror to observe the teeth of the patient. Okay. So this case only when you place the object is placed between F and P. So image will appear virtual, erect and enlarged. Okay. Compared to the object, image size is increased. Okay. So here very very important. Just check once here. So pole. This is a pole. Focus, center of curvature, object is placed between F and P. One light I am taking like this. So another light ray is incidenting at pole. So it will be reflected. Okay, so here you can see object is placed between F and P. Image will form behind the mirror. Nature of the image is virtual, erect and enlarged. Compared to the object, image size is increased. Okay, so very very important. So make sure that you are learning this point. So these points are very very important. Is it clear? So I hope it is very clear. Next one. So we'll discuss about convex mirror. Okay. Convex mirror. So convex mirror, only two cases are there. So here I am taking the convex mirror. So pole, focus, center of curvature. Object is placed at infinity. So image will form. So at focus, here also at focus only. Object is at infinity. Image is forming at focus. Nature of the image is virtual, erect and highly diminished. Point number 1. Coming to the point number 2. So here you can observe object is placed. So pole, focus, center of curvature. One light ray I am taking like this. So after that it will be reflected back. Another light ray is incidenting at the pole. So if you are extending these light rays, those light rays will meet. The image will form between P and F. Object is placed between P and infinity. Image will form between P and F. Nature of the image is virtual, erect and highly diminished, we can say. We can't say highly diminished because here highly diminished. Point size image is formed. Virtual, erect and highly diminished. So because it is point size image. Okay. So here diminished. So we can say diminished. Understood or not? Diminished image will form. So diminished image will form between P and F. Is it clear? Right. Next one. Next one. So that is about ray rules and image formations of concave mirror and convex mirror. Ray rules and image formations of concave mirror and a convex mirror. So now we will discuss about sign conventions. Sign conventions we can see. So I'm taking here this a concave mirror. Concave mirror. So all measurements will be taken from the pole. So in this direction positive, opposite direction negative, above the principal axis positive and below the principal axis negative. All measurements will be taken from the pole in the direction of incident rays. All measurements will be taken from the pole in the direction of incident rays. All are positive. Opposite incident rays all are negative. Above the principal axis positive. Below the principal axis negative. So these are the sign conventions. Understood or not? So very important as like coordinate axis. So you can take positive x-axis, negative x-axis, positive y-axis, negative y-axis. All measurements will be taken from the origin here. So with the help of coordinate axis, we can take layer. But coming to here, sign convention, all measurements will be taken from the pole in the direction of incident rays all are positive, opposite incident rays all are negative, above the principal axis positive, below the principal axis negative. Understood? Yes. Coming to the next one. Coming to the next one is mirror formula and magnification. Mirror formula. So here 1 by f equal to 1 by v plus 1 by u and magnification equal to minus b by u, that is nothing but height of the image by height of the object. That is nothing but magnification of the spherical mirror. So concave mirror and convex mirror. So next one. So we'll discuss about refraction of light. So coming to refraction of light, refraction. Okay, refraction is nothing but, so I'm taking this rarer medium and denser medium. Rarer medium and denser medium, when light rays passing from rarer to denser, it bends towards the normal light. So here you can take when light rays passing from rarer to denser, so it bends towards the normal line. So here angle of incidence and angle of refraction. So from the first case, angle of incidence is greater than the angle of refraction, because when light ray is passing from rarer to denser, it bends towards the normal line. So if you are taking the second case, if the light ray rarer medium, denser medium, if the light ray is passing from denser to rarer, if the light ray is passing denser to rarer, so the angle of incidence, angle of refraction. So angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence. So very important. So in this case, when light ray is passing from rarer to denser, in the denser medium speed is decreasing, that's why it is moving towards the normal line. So in the second case, light ray is moving from denser to rarer, so speed is increasing, that's why it is moving away from the normal line. So that's why angle of refraction is greater than the angle of incidence. In this case, angle of incidence is greater than the angle of refraction. Understood or not? I hope it is very clear. So next one we will discuss, when the light ray is passing along the normal line, no refraction takes place, no deviation takes place when the light ray is passing along the normal line. And one more point, so the refractive index of two mediums are same. If two refractive index of two mediums are same, then no refraction of light takes place. It is passing along the normal line, no refraction takes place. Understood or not? So now we can observe here. So we are taking, yes, so glass slab, or one more point is there. So this is a rarer medium, denser medium. So this is the source. Light ray generally, if it is passing from denser to rarer, what happens? It moves away from the normal line. Okay, so if the light ray is passing from denser to rarer, so what happens? It moves away from the normal line. It moves away from the normal line. Understood or not? It moves away from the normal line. Okay, so that is a refraction of light. That is a refraction of light. Is it clear? What is that? That is a refraction of light. Okay, done. So same from the point here, this is the angle of incidence and angle of refraction. angle of incidence and angle of refraction. So if the light ray is coming from the source, so here it is coming, so after refraction, so that certain angle of incidence, generally I'm keep on sending the light ray, from denser to rarer, denser to rarer, denser to rarer, denser to rarer. So what happens at the interference of the rarer to rarer medium, denser medium, at the interference of the rarer medium, denser medium, the light ray passes, the light ray moves away from the normal light, so this is the normal light, moves away from the normal light. Understood or not? So that is a refraction. But generally, when light ray is passing from denser to rarer at certain angle of incidence, the refracted ray passes, gauges or moves along the surface. Okay, so here if it is passing along the surface like this, so this it makes 90 degrees with the normal line. This the angle of incidence. That angle is called critical angle. So because of this angle only, right, the light ray is refracting along the surface, the refracted ray passing along the surface or moving along the surface. Okay, so yes, so it is also making 90 degrees with the normal line. That angle is called critical angle. And here, so the light ray is passing here. Okay, at certain angle of incidence, the light ray bends towards C. The light ray bends into the same medium. This is the incident ray. So this angle of incidence. So it is making more than 90 degrees. 90 plus theta. Okay, so more than 90 degrees, then light ray reflect back into the same medium. Light ray will reflect back into the same medium. So this phenomenon is called total internal reflection. If the light ray is passing from denser to rarer, in the rarer medium, it is the light ray making more than 90 degrees, 90 plus theta, more than 90 degrees, then light ray reflect back into the same medium. This phenomenon is called total internal reflection. I hope it is very clear. Next one. So next one we will discuss about one more, that is glass slab. So actually here we need to discuss about laws of refraction. So okay, so with the help of glass slab I will discuss laws of refraction. So this is the incident ray and this one is the normal line, then this one is the refracted ray, and this one is the emergent ray, and this one is the normal line. And here if you are taking this is the initial direction. Normally the properties of rectilinear propagation of light, rectilinear propagation of light moves in a straight line. If there no medium is there, so in the path of the light ray, then it moves in a straight line path. Okay, so if any medium is there, so it depends on the size of the particles, either bending of light ray takes place or hitting and splitting into two parts, it depends. So here if the light ray is passing along a straight line path, so this is initial direction of the incident ray. So the distance between emergent ray and initial direction of the incident ray is called lateral shift. I hope it is very clear. So the angle between incident ray and normal line is called angle of incidence, angle of refraction, angle of emergence. Understood or not? I hope it is very clear. So we know laws of refraction. Point number one. So incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. So that is the point number one. Coming to the point number two. So coming to point number two, that is the ratio of sine of angle of incidence to sine of angle of refraction equal to constant. Sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but refractive index n. Okay, so here there are 2 points are there. One is absolute refractive index. refractive index, that is absolute refractive n equal to c by v. So coming to relative refractive index, relative relative refractive index, that is, so you can see, so n12, that is nothing but n1 by n2 equal to v2 by v1. Sir, why you are taking v1 v2 by v1? Because inversely proportional. v2 by v1. Here from this n is inversely proportional to velocity. N is inversely proportional to velocity. Refractive index is inversely proportional to velocity. That's why this absolute refractive index and this one is a relative refractive index. Relative refractive index n12. Whatever the medium comes first, that you have to write in the numerator, and the next medium you have to write in the denominator. That is n12 equal to n1 by n2, that is equal to v2 by v1. v2 by v1. Understood or not? So, and also we can write n21, that is nothing but n2 by n1. So n2 by n1, that is nothing but v1 by v2. v1 by v2. I hope it is very clear. So this is about here n2, here we have to take n2 by n1, that is nothing but v1 by v2. Okay, so next one here, so we have to place the pencil inside of the glass tumbler. So here this is the lateral shift. So here you can observe, so I am placing the pencil in the glass beaker, so it appears bent at the interference of the water and glass. So here if you are taking this, so in this case at this region it appears to be bent. Actually this is the position at the interference between water and, so water, this is the water and air. At this interference it appears to be bent, but actually it is like that only. So and one more thing, so normally the person is here, so we place the coin at the bottom of the beaker, understood or not? So he can't able to see the coin from this position. From position A, he can't able to see the coin placed at the bottom of the beaker. After pouring water, the coin position rises up. So this is the upper end position. So the distance between this actual position to upper end position of the coin is called vertical shift. This is the actual position of the coin and this is the vertical position of the coin. So actual position and upper end position. Okay. So the distance between actual position to upper end position is called vertical shift. Understood? Even you place the lemon inside of the beaker also. So you can observe, you can go to shops, near to the shops, in front of the shops, they'll place this lemon. Okay, they'll place this lemon, then it appears bigger. Did you observe any time? So when you go to shops, so there is a water inside of the glass, that too with the lemon. Okay, so lemon is placed inside of the glass. Okay, so it appears bigger. Due to refraction of light. I hope it is very clear. So that's enough. That is about refraction. And coming to the spherical lenses. We'll discuss about spherical lenses. Here convex lens and concave lens. Convex lens is also known as converging lens. Concave lens is also known as diverging lens. When light rays falls on the convex lens, it converges the light rays and make it falls at one point on the principal axis. And even for concave lens also same. So now we can take, so ray rules of convex lens. This is the convex lens. Ray rules: point optic center f1, 2f1, f2, 2f2. Okay. So light ray is coming from infinity after reflection. So it passes through focus. So point number 1, and coming to the point number 2, light ray is passing through optic center f1, 2f1, f2, 2f2. So light ray is passing through focus. So after refraction it moves. So it moves towards infinity, become parallel to the principal axis. Understood or not? So like this. So I'm taking here. And coming to the third one, lens, convex lens. Okay, optic center, F1, 2F1, F2, F2, 2F2. Okay, so here is F2 and 2F2, F2 and 2F2. So light ray is passing through optic center, no deviation takes place. So this is a convex lens, and coming to the concave lens. This is a concave lens. So I'm taking the concave lens like this. Okay, so here optic center F1, 2F1, F2, 2F2. So light ray is coming from infinity after refraction. So it diverges light rays. After refraction, it diverges. So here, point number 1, if you are extending the light rays, it passes through focus. Coming to the next one. So here you can observe optic center F1, 2F1, F2, 2F2, F2, 2F2. So if the light ray is passing through F2, so it will move. And coming to third one, okay, optic center F1, 2F1, F2, 2F2. So here you can observe light ray is passing through optic center, no deviation takes place. Understood or not? So I hope it is very clear. So just check once. These are the points. Okay. So we'll take small break.